All right, now we may consider decimal power and base. What this actually, this may not really be regarded as one of the laws of indices, but in case whereby you have decimal in either the power or the base, the best approach for you to solve it is first of all convert it to a fraction. When you are done converting it to fraction, you can solve it. Then after solving it, you now can return back to decimal if need be. Okay, for instance, if you have maybe 0.16, okay, raised to power minus 2, for instance. Okay, now remember our negative power. Okay, now if you have this, what this will give, we are going to do, rather respond to this decimal power and base, because this one now falls on the what? On the base. The decimal falls on the base, which is this. Now what you simply do is you take you say 16 over 100. Remember, 16 over 100 already has taken this off from here to what? To fraction. Now you also have your minus 2. Okay, you can go further and say this is equal to, remember our negative index. Our negative index says that when a number is raised to what? To a negative power, you take the reciprocal of that number. In as much as we have already gotten a fraction, we are still going to take the what? The reciprocal of that number. Okay, now how do we do it? We can simply say 1 over 16 over 100, or this raised to power 2. Okay, because this is the number. Now from here you can say 1 over square root of, or rather square of 16. Okay, square of 16 will give us what? Will give us let's say 16 times 16. This is 36. We have 6 carry 3. This is what? 6 plus this 9, and this is 16. From here we have what? 6. We have 5. We have 2. 2, 5, 6. We have 2, 5, 6 all over. Now coming to this, we have that the square of 100 will give you 10,000. Okay, sorry, if we have sorry, if you have 100 rather, because it's multiplying by what? Another 100, you can take the 0 here and add it to this. We have 10 with this 20, we have this. So this is what? 10,000. Okay, now from here you are going to take the reciprocal of this number again, so that this number, this 1 over will go, or you can simply maybe reduce it first. So whichever way you want to go about it, you can actually do that. If you say maybe dividing it by something like 4, for instance. Okay, 4 divide here, we have what? We have 6. Okay, remainder 1. Put that one here, divide it by 4, you have 64. Okay, and 4 divide 10 here, we have 2. Remainder 2. The 2 moves to this place. Okay, now becomes what? 2000. The first 0 here with that 2 will give you 20. So 4 into 20 will give you what? Will simply give you 4. Simply give you 5 rather. Okay, now 5. Now you check this 0. 4 into 0 is what? 0. Now with this again, you can still divide by 4. If 4 goes here, you have 1. Remainder 2 goes here, you have 16. Now 4 into this place, you have 24. It can only have enter into 24. We have 6 rather. Now 1 remainder here, we put that one here. That one will give you 10. If you divide if you divide 10 with 4, you are going to have what? 2. Okay. Now remainder 2. You put that 2 here, it becomes what? 20. 4 into 20, you have 5. Okay. Now with this again, you can go ahead again and divide by okay, you can now say, okay, this is equal to 1 over 16 over 625. Okay, now you take you want to eliminate this 1 over this thing. What this simply will give you is what? Inversing this, we have 625 over 16. Okay, so that is what this means. Okay, nothing can divide this at this point. Now what you do, you are going to return it back to the decimal. Okay, when you want to return it back to decimal, you simply say 16 divide this. Okay, quickly, 16 divide this. What will it give us? 39.1. approximately 39.1. So this will now be the final answer. All right, now we are going to do some illustration or give some examples to illustrate on the laws of indices we have already treated. Okay, all right, so stay tuned. All right, so still on laws of indices. We have example 1. Simplify the following. Number 1, 3 whole number 3 over 8, all raised to power 1 whole number 2 over 3. And the second one says 16 raised to power 25, all raised to power 1.5. Now, solution. The first one says 3 whole number 3 over 8, all raised to power 1 whole number 2 over 3. So what you are going to do here is remember the decimal power and base. If you look at this now, at the base side we have what? Fraction instead, and at the power side we also have what? Fraction, and the fractions are what? Mixed fractions. So before you solve this kind of illustration, you first of all convert them down to, or rather back to what? To improper fraction. Okay, you convert them to a single fraction, which will give us improper fraction from here. Now we say equal to 3 times 8 will give you 24. 24 plus 3 will give you 27. So we have 27 over 8. Okay, now the power, we go to the power. We have that 1 raised to power 1 whole number 2 over 3. So we say 1 times 3 will give you 3. 3 plus 2 will give you 5. So 5 over 3. Now from here we move. We say if you remember your fraction index. Okay, fraction index. Here we can have that that we're going to take the cube root of the number, and after you must have gotten the value, you raise it to power 5. So this will give you cube root of 27 is what? Is 3. So we have 3, because 3 times 3 is 9. 9 times 3 is 27. Now cube root of 8 will give you 2, because 2 times 2 will give you 4. 4 times 2 will give you 8. all this raised to power 5. Okay, now with this we go, we say so here we now have this. So with this you can, okay, so from here now you can simply say 3 raised to power 5, that is equal to 3 times 3 times 3 times 3 times 3 all over 2 times 2 times 2 times 2 times 2. Now, assuming these base are the same, now you would have cancelled out this 5, but since they are not the same, there's nothing you can do here than to multiply it out. And when you do that, you have this times this times this times this times this will give you 243 over this times this times this times this times this times this will give you 32. So this becomes the final answer. Okay, so we'll move to the second example there, or rather the second number, 16 over 25 all raised to power 1.5. Okay, for the second number we have 16 over 25 all raised to power 1.5. Now at this point we're going to convert this to fraction. Okay, now we have 16 over 25 all raised to power 15, rather 1.5, just like saying 15 over 10. Okay, 15 over 10. Now from here we can say okay, we can even cancel out first. We say this 5 into this we have 3, 5 into here we have 2, so we end up having a 16 over 25 all raised to power 3 over 2. Okay, now with this, now we take the square root of this number raised to power 3. So quickly we have square root of 16 will give you excuse me, will give you 4 over square root of 25 will give you 5 all raised to power 3. Now quickly we have 4 times 4 will give you 16. 16 times 4, 16 times 4 will give you 64. Okay, now we have 5 times 5 is 25. 5 times 25 will give you 125. 125. So this becomes the final answer. Okay, all right, now we're going to take the second example. Okay, so stay tuned. Okay, the second example says simplify the following: 27 raised to power 1 over 3 and 64 raised to power minus 1 over 6. Then second one says 16 raised to power 5 over 4 times 2 raised to power minus 3 times 3 raised to power 0. Solution. Now the first one says 27 raised to power 1 over 3 over 64 raised to power minus 1 over 6. Now from here we can say equal to. Now we're going to take this differently. We're going to be handling the numerator and the denominator, whatever we are, by simplifying it first. Then once we arrive at the end side of it, we look at it. If it's something we are going to work out the both between the denominator and the numerator, we do that. If is not possible, then we end it as the answer. Now we take off. Now coming to this numerator, we have 27 raised to power what? I mean, rather, we take the cube root of 27, okay? Remember, okay? So from here now we have 64 raised to power 1 minus 1 over 6. So in this case, what we are going to do is this. We say over 1 over 6th root of what? 64. Okay, do we understand that? 6th root of 64. Now from here we can say equal to, now cube root of 27 is what? Is 3. Okay, 3 over 1 over, now 6th root of 64 will give you what? Will simply give you, if we say 6 times, I mean 2 times 2 times 2 times 2 times 2 times 2, you find out that when you say 2 times 2 here is 4, 4 times this 2 is 8, 8 times 2 here is what? 16, and 16 times here times 2 here is what? 32, and 32 times this 2 is what? 64. You find out that if you take 4, if you distribute, rather if you distribute 2 into 6 different places, you are going to get what? 64. So what that simply means is that 6th root of what? 64 is what? Is 2. Now remember this. What this simply means is what? That this 3 is being divided by what? 1 over 2. So in that case, you say 3 over 1 times, take the reciprocal of this, you have what? 2 over 1, and this will give you 6. That's the final answer. So quickly we'll go to the second number. Okay, all right, quickly, the second one says 16 raised to power 5 over 4 times 2 raised to power minus 3 times 3 raised to power 0. Now if you remember these are expressing different laws of indices. Okay, for this we can have fourth root of 16 all raised to power 5 times, now you come to this, you have what? 1 over 2 raised to power 3. Okay, now you come to the last one. This is 0 index law. We have what? 1. Anything raised to power 0 is 1. So from here we can say, okay, what's the fourth root of 16? Simply we can have 2. Okay, 2 raised to power 5 times. Now for this we have 2 raised to power 3 is okay. Yes. Okay, let's still have 1 over 2 raised to power 3 first times 1. Now from here now we say, okay, 5 raised to power 5, 2 raised to power 5 rather is saying 2 times 2, 4, 4 times 2, 8, 8 times 2 is 16, 16 times 2 is 32. So we have 32 times. Now for this we say 2 times 2, 4, 4 times 2, 8. So we have 1 over 8 times 1. So from here now we can say equal to 32, or rather we can cancel out. You can say 8 here 1, 8 here is what? 4. So you multiply what you have at the numerator side is 4 times 1 times this one, we have what? 4. 4 raised to 4 over what? 1, which is equal to 4. The final answer. All right, so with this I believe a little understanding on law of indices has been expressed. So quickly we are going to move into exponential function. Okay, All right, with that, I think we end this index notation and function. All right.